Good morning to everyone. I'm Manuel Zambelli. I'm a PhD student in Advanced Systems Engineering at the Free University of Bolzano. And my supervisor is Professor Barbara Russo, and she is also coordinator of the PhD program in Advanced Systems Engineering, and will try to answer the question, can automated response to cyber incidents be supported by artificial intelligence? I had the opportunity to do an internship in CIRC, in Informatica Alto Adige, where I could work together with the SOC team and the security specialists in the SOC team to see some technologies and also to see how they work. So before I try to answer the question, I would like to explain the motivations, why I have chosen two proposals. You will see two proposals in this presentation. And I will give a bit of background. For example, what are log files, why log files in an information system and or in a computer network are generated. I will give some basic explanation about the SIEM, the security information and management and event management, the SOAR, the security orchestration, automation and response. And I will explain why we need manual labeling for AI integration for cyber incidents, and what are incident descriptions, and how we can generate a vector for incident descriptions. So the first motivation is that we have false positives. Some products are already AI supported by AI integration. And in machine learning, we have the problem of false positives. And for example, we can have that cyber incidents, which are classified either as, for example, with an alarm. They can be misclassified because the CM, in our example, is not able to classify them correctly. This can be, for example, a user which tries to log in many times before he can successfully log in. Or, for example, there is an unauthorized access, but without malicious intention, without stealing data or something else. And these false positives can increase the cost in the company because the security specialists have to look over the output of the machine learning algorithm. So the second motivation comes from the NIS2, this is EU directive 2555, and the Italian NIS is the Decreto Legislativo number 138 of the year 2024. And starting from next year, companies have to report incidents of a significant impact to the CSIRT in Italy, the Computer Security Incident Response Team. And this can be, for example, if there is a data leakage, if there is a loss of confidentiality or a loss of integrity in the data, then they have to report this. And the ACN, the National Cybersecurity Agency, provided a taxonomy, and they describe how incident notification can be, the reporting of incident notification can be simplified. And these are the taxonomy is composed of 4 macro categories. So in computer network system, many devices, for example, servers or other network devices, they generate logs. These are chronological events. And for example, when we have unsuccessful login, we will see there that the login was not successful. And the SIEM, the Security Information Event Management, that is a product which, the basic tasks is a product which collects the logs from different devices, for example, different types of servers, for example, Apache servers or endpoints, security endpoints, or also from next generation firewalls. These are only a few examples. I don't show all examples, all possibilities. It collects logs, it parses the logs, and it takes a decision. For example, it can generate an alarm, and the alarm is, for example, can be sent to the SOC team, to the Security Operations Center, to the security specialists. And we'll see later what is the task of the SOAR. And the security specialists have to take into consideration this notification. So there are some CM solutions. I don't want to go deeper in the commercial CM solution in the first four. And, but there are also open source solutions. And we plan in the university to introduce some open source solutions. For example, there is Elasticstack and some other minor open source solutions. So the SOAR, we can also include a SOAR. Maybe some products include both CM and SOAR, but SOAR can be also a different product installed on a different server. And the SOAR takes the generated alarms from the CM, and it can initiate automated responses. This can also be done by a security specialist. If a security specialist, also a security specialist can work instead of a CM. He or she can, for example, analyze logs, parse logs, and decide if there was a real attack. This is, but this can be done by a CM and also for a SOAR. For example, a security specialist can decide, okay, there is this alarm, what should I do? Should I, for example, analyze the IP address? Should I perform a URL reputation analysis? Should I report this type of malware, if this is effective malware or a ransomware? Should I report this to the MISP, for example? And the SOAR can help the SOC team. And okay, for our experiments, we used this Splunk SOAR. There is the possibility to install this on premises, and with some limitations, you have the possibility to use the free community edition. To get your hands dirty, you can perform some tests, you can start some playbooks. By the way, the playbooks can be written in Python, for example, but not only in Python. And there are Phantom community playbooks. There are a lot of playbooks. You can find them, you can use them, and they are under the Apache 2.0 license. So, possible methodology to integrate AI in the SOAR, because many CM products are already AI supported. So a possibility to integrate the AI in the SOAR can be, we asked some specialists, not only one specialist, but more specialists, to take this incident, these reports, and to decide, is this really alarm, is this a real incident, or was this a false positive? So we need some specialists, and they should manually label the incidents in order to have a ground truth. And we can suppose that we train a machine learning model, so the human gives a label, 0 or 1, and we can train a machine learning model, and the machine learning model learns about the mistakes. And this is supposed, we can think this as a continual learning with human feedback, for example. So we see here the incident descriptions. The incident descriptions, they come from the SOAR, indirectly from the CM, because the CM generates these incident descriptions, and it sends the incident descriptions to the SOAR with the alarm. And these incident descriptions, maybe they contain, for example, the description itself. It is, they come from a rule, these descriptions. And maybe they contain the IP address, or they contain some additional information. So here in this product, we see it is very simple to create a new label. We already have a label in specific products. You have standard containers. Container can be a JSON file, and with different fields. And for example, there is the field for the incident description, or there is the field for the IP address, the field for the timestamp, and so on. And there is already a label most of the times, for example, the label event, but we can consider to introduce a new label, for example, this manual label, or we can call it incident, and we can ask the security specialist to label this incident. Okay, here we see we have done some experiments with artificial incidents, artificial containers. We injected some artificial incidents, and but in a company, for sure, you will get these real incidents, these real descriptions. So this could be a possibility for the AI integration. And for example, we have the SOAR. The SOAR is either a cloud solution or it is an on-premises solution. I installed the on-premises solution on my notebook to do some tests. And if you want to separate the SOAR and the machine learning model, in theory, it is possible to integrate the machine learning model in the SOAR because this SOAR is installed on a Linux distribution system. Linux operating system. There are many you can choose. I choose one which worked best as a Linux operating system. And you can install Python libraries. You can install, for example, TensorFlow. You can install a lot of libraries. But if you want to separate the SOAR from the machine learning model in order to have two different machines, then you can, for example, get the description. There are API endpoints. You can get the container with the whole incident. You can take a decision with the machine learning model, and then you can maybe post the new container, and this new container initiates a playbook. Here we will see, you can see the a playbook with the visual playbook editor. And this example takes the data, it chooses a format, and then it sends a ticket to the security specialist, to the SOC team, for example. So there are some playbooks. As I already said, these are Phantom community playbooks. You can find them. There are also the visual playbooks. There are some examples on in internet, but most important are the playbooks on GitHub under the Apache 2.0 license. And there is a specific Phantom library for Python you have to install so it can work, so it can process and elaborate the incidents. So now we go to the second motivation. This is the taxonomy of the National Cybersecurity Agency. And this taxonomy provides 4 macro categories: the baseline characterization, the threat type, the threat actor, and additional context. For example, the threat type can be, is this a ransomware, is this another type of malware, is this a Trojan? Or for example, additional context, maybe there is the need to have some additional information about the operating system or something else. These macro categories are divided in predicates. And so here we see, again, the 4 macro categories. And for example, for the baseline characterization, there are 4 predicates: the impact, the root cause, the severity, and the victim geography, for example. And the threat type, it has many predicates. And for the threat actor, there are 2 predicates and the additional context. So here, an example, because I have, in a previous slide, we have seen that there are 4 macro categories, and in total, 22 predicates, and in total, 144 values. And the values are grouped in the macro categories and in the predicates. And for example, here we see the 9 values for the baseline characterization and the impact, and the predicate impact. This could be a classification: is this a data exfiltration or a data exposure or something else? This is an example of a TC-ACN vector. So this is not a human description of an incident. This is a vector, a mathematical vector. You can see, for example, this can be a real incident. okay, I don't explain all values. This vector is composed of many values. And so, for example, this vector says, yeah, the impact was a data exposure of this incident. The root cause was, in general, a malicious action, not a human error or a system failure or so on. The severity maybe could be low, medium, or high, or not specified. The victim geography is not in Italy. Maybe the victim geography is the whole Europe. Maybe a data exposure, personal data, loss of personal data. And malicious code, a backdoor, and I don't explain the other values because you can compare the other values with the official document of the ACN. So some of you know the MITRE attack framework. It provides many adversary tactics and techniques. A hacker, in theory, can use one of these techniques, tactics, and/or techniques. And they have a code, all these tactics and techniques, but if you have an incident description, maybe you don't have the exact code. You have an incident description made by human or made by a rule which has been defined in the CM. So this is our proposal for this second methodology. For this second problem, we have the TC-ACN taxonomy. It is a document composed of 57 pages, but relevant information, you can find the relevant information in 37 pages. And so we tried to do, this is a huge document. For an LLM, for many LLMs, this is a huge document. And we tried to do a manual summary. We were able to generate approximately, I think, 4,000 tokens of this summary. So this is a very brief summary of the whole document. We have chosen a prompt template, and for sure we get the incident description from the SOAR. And merging all these three things, we generate a prompt for an LLM, and we are supposed that this LLM produces the correct TC-ACN vector, so we can use this TC-ACN vector to report an incident. So how did we generate the prompt? We use the persona pattern, and this is the exact example for our first prompts. We tell the LLM in the prompt there is written, you are part of a SOC team, your role is the security specialist, consider the incident description which we get from the SOAR, not the code, but the human description or the description which comes from a rule defined in the CM, for example, and generate the TC-ACN vector in the correct format according to the TC-ACN taxonomy, which is provided in the summary, in the small summary of the whole huge document. So this could also be automatized. Again, if you want to separate, to don't have all servers, all parts on the same machine, we can think that we split the SOAR and local server. This can be, for example, a web server or another type of server. There are, nowadays, there are also MCP servers, and there is the possibility to install an MCP server. But maybe also a normal web server works. We can think we have to provide the endpoints in this web server. We can think to send the incident description to this local server. It should all servers should be locally. We don't want to ask some LLMs which we can find in the internet and disclose our incidents. We want to have all locally. So maybe we can provide three different machines and also the local LLM. We tried the local LLM for our tests, for our first tests. And so, for example, the local LLM can retrieve the incident descriptions from this local server, which we can suppose there is this database, and we try to generate the TC-ACN vector. So we have some preliminary results. We used the GPT-OSS 20B model, which can run on a notebook, on a small notebook without GPU cluster, without anything. We tried this thinking feature of this model. This is the smallest model of GPT-OSS. And with the smallest context length, 4K, only 4K. And I don't show data from the company, but I tried to generate synthetic data. I tried to use also manual generated incident descriptions, but these are synthetic data generated by an LLM. For example, this could be an incident description, potential DOS attack detected. So this is the real result of my setup on my notebook with this small configuration. Okay, we see, if we analyze these values, some values are correct. I verified this. Some are still wrong, so we have to work on that. Also, ChatGPT has some problems to generate the correct vector. This is a second example. We have more examples, but this is a second example. Web application exploited through SQL injection. Also here, the same configuration, the same model, the same context length. And this is also a synthetic incident description, which is generated. And also here, there are some wrong values. Some are correct, some are wrong. Okay, does not change. Okay. So we arrived to some conclusions, and we have proposed two solutions how we can integrate AI in our models, for our SOC team, for our security specialists, to help them and to support them in their work. And for example, the first solution was to address the false positives, but for sure this needs that we provide a ground truth, and we need human feedback, at least in the beginning. We have seen that there are phantom community playbooks. We can use them, we can share them with others. They are written in Python. If you don't like the visual graphic editor, we can use the Python, we can program in Python, we can install new libraries. And, but these basic concepts can be applied for sure to different software solutions. We have seen a brief introduction in the taxonomy provided by the ACN, the National Cybersecurity Agency. We propose to leverage local LLMs, not LLMs which we can find in the internet, but local LLMs maybe installed on our notebook. And we have seen, for sure, there is a bias problem. Because, for example, we have generated the summary. We have generated the summary of the huge document. So there is for sure a bias in this generation of the summary. Maybe we need to do it in a team. Or what can be helpful, we ask another LLM to help us to generate this summary. But for sure, at the moment, there is some bias problem. And maybe we can replace, you have seen some persons, for example, and maybe one person can be replaced by an LLM. And for sure, we need to fine-tune the LLMs with examples. So we didn't do this, but for sure, we need to provide for our LLM some basic examples. We have to generate some basic vectors, and we have to provide some examples. So this work was co-funded by the Italian MUR with NRRP funds. And there is a project number, and in our team, we want also to acknowledge and to thank the SOC team in the SIAC, and especially the head of the department, engineer Francesco Terracciano, and also the one security specialist, Abdul Rahman Hawajay, and they help us a lot to try technologies, to get feedback, and maybe to continue for this work. So these are some references and links I used for this presentation. I used for my work, for my a part of my research project, not the whole research project I'm doing during the PhD. And okay, we reached the end of the presentation. I want to say something about our cybersecurity lab. You can reach our cybersecurity lab on the webpage of the UniBZ. And if you have any questions, we would be glad to answer your questions if there are some clarifications needed or something else. Thank you very much.
Grazie Manuel, direi che la sala si è popolata, avevate 35 minuti per arrivare, siete arrivati tutti dopo l'inizio della sessione. Scherzi a parte. Oh yeah, let's switch to English, sorry. Thank you very much for your presentation, Manuel. Is there any question about the interesting topic that was how AI can help managing in an automated way incident response? This is a matter that will matter even more in the future because due to all the regulation that is actually complicating the things, we need the security staff find themselves into managing technical stuff and administrational stuff, that is reporting, a lot of Excels, a lot of codes to cope with. And this is a great job for AI. AI is very good at dealing with that. While they think that their question, I'm going to make you one. It is, why did you try to use a standalone LLM instead of a cloud one?
No, I wanted to have all on my notebook. I wanted to install a minimal configuration and test if this could work. And to have all on my notebook, maybe we can deploy this for a company or for some people on a dedicated virtual machine on the server or something else, not use the cloud.
You talked about some problem creating the right description for the ACN. What kind of problem did you face there?
Description according to the vector.
Yeah, what kind of problem did you face actually?
Some values are wrong.
Some values are wrong.
They are wrong, they are not, we cannot find them in the taxonomy.
So it was basically an hallucination. Did you try the same prompt on the cloud version of the LLM?
Not yet. I tried another LLM, which is not open source, and also that answer was not perfect. So there is a need of maybe to provide some examples, I suppose, but we have to do research on it.
Okay. Questions?
Yes, hi. We are building something similar at my work. My question would be...
Just 1 second. So everybody can hear your question.
Yeah, thanks. So we are building something like this where I work. And one of the things that I'm super interested in is how big do you think this grand database provided by the humans with examples needs to be so the data is, so the output is more reliable?
For the second problem, for the second motivation,
yes.
The database of the fine-tuning, you mean the database of the fine-tuning?
Yes, yeah, like...
So how many examples?
Or the labeling that humans do, yeah. Like the examples that, like you need a database built by experts, so then
yeah, I think we have to cover many different attacks. I think that is my opinion. Maybe it could be, I don't have the exact number. Maybe it could be 200 or 300, but I don't have the exact number.
Yeah, there is
for sure not 2 examples.
Right, okay. Cool, thanks.
Thank you. Down there. really down the corridor. Here we go.
Thank you. From your perspective, what is the most critical factor to improve in order to have a production-ready solution? So,
in order to have
a production-ready solution which is delivering results which are accurate enough in the real world of business. Sorry.
Okay, in my opinion, for example, the prompt has to be optimized. It has to be validated by more humans. I think we have to collaborate with security specialists. We can do research, but we have to collaborate with security specialists. So to analyze and to validate the output of our tests. So I think the integration of the AI could be helpful, to integrate AI or to replace the human with AI, but also to have a team of 2 or 3 specialists which work together and who work together and they have to validate. I think that is my opinion.
Is it okay? Any more questions? I have another question for you. You talked about a cybersecurity lab, but you were very short on that. What do you do on that?
Maybe my supervisor wants to add something. She is a very good
She doesn't want to, but since we got 2 minutes and a half, I must ask you to do a little presentation that because if you can avoid telling that and everybody's happy.
No, okay.
You say everything about that, everybody's happy. If you just say, yay, no, everybody are crazy about that. So
Say, afterwards, you know what. Okay, anyway.
you are listening to Barbara Russo, that is a professoress, right?
Yes.
At the Free University of Bozen.
So in computer science, okay. Just one question, one answer to you. I mean, he's just the first year, so I think we have a long run to have a solution that works. And also the solution needs to be customized for the specific system. We are trying not to provide a framework that works, also to help for the NIST tool, the automatization of the thing. But he's just the first year, so this is his idea at the moment. So the CS lab is our big laboratory in which we have a cyber ranch. A cyber ranch is a platform in which we can represent a system as a digital twin and then test it for cybersecurity. So attack it, defend it, and we can incorporate different virtual components and then we can test them. So for example, if you wanted to add a new component and you don't know whether there is any security issue in this new integration, then we can test it and see whether there is any problem, any weakness with that component. That's the basic thing of that. It costs a lot, so we have just purchased it now, so the cyber ranch is now there, we test it, so we are ready to use it next year, 2026, since the beginning. So we want to provide this service to companies, and that's our idea. So another important thing is that laboratory is completely protected. And when he said that he tried on his own computer everything, not on the cloud, we don't want to go to the cloud until we know that everything is secure. So that's the reason why we are trying to. So the lab is completely protected, it's its own IPs, independent, and we want to secure that everything that enters doesn't go out anyway, right? That's the idea of that lab. So we are purchasing this lab is being funded by the FESR as infrastructure. So we are purchasing everything in the world in order to provide services for cybersecurity.
Perfect, Ms. Russo. Thank you very much.